acknowledgement that it has done that one, and then DMA can perform the operation. So this can be done, this can be possible by causing an interrupt. Okay, so the normal function of the CPU will be interrupted, and the particular controller who is requesting for a particular operation to be performed, like DMA controller, direct memory access controller, means suppose a particular device required to access memory directly. At that time, that request will be generated by the DMA controller to the CPU to stop its operation for some time, and at that time that DMA controller can do the particular operation. Okay, so that is called the interrupt. Interrupt is required to be caused so that the device controller can do the particular task. Now, common functions that are present in the interrupt. So if you study interrupt, there are different types of interrupt, like your trap is a kind of interrupt. Then you have the request interrupt. Okay, also the restart interrupt. So restart, there are, if you study the microprocessor, okay, there is 8085. Okay, is there any question, anyone? Is someone is on? Any question? Hello, can you hear me? Hello. Hello.
Yes, sir. Listen.
Okay, okay, fine. Okay, so I'm telling that when we will study about the microprocessor, okay, 8085 microprocessor, then we will study about different types of interrupt. Okay, there we have RST, okay, restart interrupt, which is the restart 5.5, then restart 6.5, then restart 7.5, and then trap is there also. Okay, so there are different types of interrupt. By using that, we can stop the operation of the microprocessor for some time, okay, for different reason. Now what is happening here is that interrupt transfer control to the interrupt service routine, that is generally through the interrupt vector. So interrupt vector is actually is working here to transfer the interrupt control, okay, to from the to the particular interrupt service routine. So interrupt service routine means what? That next interrupt will happen at what time and for which reason, okay, and from which address. Means that suppose a CPU has different works to perform. Now CPU has given some instructions, or CPU has been assigned with some instructions, and it is executing one by one. Now from some particular address, okay, suppose the interrupt has to be done. So at that time, interrupt service routine, from the interrupt service routine, that particular location, from that particular location the interrupt will happen, and the CPU will go to the particular location where it is desired. Okay, so different types of interrupt is there, where we have trap interrupt. Trap is the highest priority interrupt, okay, that is caused in the 8085 microprocessor. Okay, and other interrupts are there, that is the interrupt request, INTR. Okay, INTR request is there, that is the lowest priority interrupt. So trap is there, INTR is there, and RST is there. So there are the three different types of RST, as I have told you, that RST 5.5, RST 6.5, and RST 7.5. Then trap is there and INTR is there, where INTR has the lowest priority and trap has the highest priority. Okay, so this is a part of the computer organization or the architecture. Okay, also the part of the microprocessor, which will be taught by some other teacher. I am telling about the operating system only, so I am telling only the basic parts. Okay, so the type of interrupts are there. So these are actually required to stop the normal functioning of the computer by interrupting the particular hardware device. That is also managed by the operating system. Next, interrupt handling is done by the which type of interrupt is actually occurred there, that you have to understand that one, that is the polling or the vectored interrupt. Okay, there are two different types of interrupt. Now if we go to the IO structure, then so input output operation means, I told you that the function of the operating system is to perform the IO management. Okay, so this IO management is actually controlled here from the by using this operation. So you can see that after IO starts, means when the IO operation starts, then control returns to the user program only upon the IO completion. Means, see that suppose some instructions are executed by the microprocessor. Now you have suppose some programs to take input from the user. What will happen? At that time, the current process will go in the waiting state until or unless you are giving some input to the program. Now when the user will give the input, at that time again the program will come in the running phase. So from running to waiting, and then waiting to ready state. Okay, and from ready to running again. So this thing is done here when the particular request for the IO to be done. Okay, you see that when IO happens, it is showing that IO instruction, that is that idles the CPU until the next interrupt. Okay, so first of all the interrupt will come, that you have to stop the execution because you require one input to be taken. Then when the user has given its input, then the next interrupt will come, that you can start your operation. Okay, and until or unless the user is giving the input, at that time the CPU will stay idle. Next, it is going to the wait loop, as I have told that waiting state is there when the CPU, when the particular program is requesting for some input, at that time it is going to the waiting state. And at most one IO request is outstanding at a time, no simultaneous IO processing. Okay, so if you have one IO request, okay, at most one IO request in the outstanding, that is outstanding there, means outstanding means that it is actually required to be given. Okay, but it has not given there. At that time IO processing will be stopped there. Okay, now when you require IO to be done, at that time system call is required and device status table is required. Okay, so system call means that is a request to the operating system to allow user to wait for the IO completion, this one. And device status table will give that the status of the IO device, that is suppose the type of the IO device, address of the IO device and state of the IO device. These are shown to the computer user for different time when the particular user is requesting for. Okay, what type of IO device, suppose input or output, then in which address it is actually locating to, then the state of the IO device, whether it is working or not, then device driver information, different things are there. Okay, for the IO devices, if you open your disk management and your your control panel, and from there if you go to the particular IO device, then you can see that what is the particular condition of the IO devices, that will be shown there, means the status of the IO devices, that will be shown there. Okay, now this is very easy actually. This thing is telling that how you can uh, define the memory. Okay, so what is memory and what is bit, what is what byte, these things are very known to you. Means bit means either a 0 or a 1, because we know that computer understands 0 and 1 only. 0 means high, 1 means 0 means low and 1 means high. Okay, these high and low voltages are identified by a particular computer. Now if you take 4 bits together, then that will be a nibble. And if you take 8 bits together, then that will be a byte. Now, any number of bit will form word. Okay, any number of bit, I mean that means greater than the one bit. Okay, so if you take 2 bit, then 3 bit, 4 bit, any number of bit will form word. Okay, now kilobyte can be found. So if you get 1 byte by taking 8 bytes together, then 1 kilobyte means that 1024 bytes. Okay, 1024 bytes will be 1 kilobyte. 1 kilobyte. And 1 megabyte means that 1024 into 1024 bytes. Okay, so this will be 2 to the power 10. 1024 means 2 to the power 10. So 2 to the power 10 bits bytes are actually forming 1 kilobyte. So 2 to the power 20, if you take this one, the next one in megabyte, 2 to the power 20 number of bytes will be there in a megabyte. Then for a gigabyte, 2 to the power 30 number of bytes will be there. For a terabyte, 2 to the power 40 number of bytes will be there. For a petabyte, 2 to the power 50 number of bytes will be there. Okay, in this way this hierarchy is classified. Okay, storage structure, you can see that storage can be random access, that is actually the main memory. Okay, where you have large storage media, but this is actually volatile. Okay, basically when the power will not stay there, at that time it will lost everything. Yeah, instead I mean also the operating system is loaded in the RAM when the computer starts, but the operating